if you've just logged in, thank you for joining us. A few housekeeping notes before we get started with today's webinar. As you're listening, you can add your questions to the Q&A section on the GoToWebinar control panel, and we'll address those at the end of the presentation. This webinar is also being recorded, so you'll be able to watch it again later. An email will be sent to you in the next couple of days with that recording. So with that, let's get started. Welcome to Continuous Delivery for Cloud Native Applications with Kubernetes, Ballerina, and Codefresh. Today from WS2O, we have Kasun Indrasiri, who is the Director of Integration Architecture at WSO2. Kasun is a key member of WSO2's architecture team that drives development efforts of WSO2's integration platform. We also have Dan Garfield, who is a full stack engineer, Kubernetes, and VP of marketing at Codefresh, which is a complete DevOps platform built for Kubernetes and Helm. So with that, I will go ahead and pass this off to Kasun to get us started.
Okay, thanks, Taryn. So let's get started with today's webinar. So for today's webinar, the topic is on continuous delivery for cloud native applications. And we'll be leveraging Kubernetes, Ballerina, and Codefresh to build continuous delivery model for cloud native applications. So let's have a brief look at today's agenda. So we'll be talking about what the main characteristics of cloud native applications and the importance of continuous delivery in building cloud native applications. And of course, we'll talk about Ballerina, Codefresh, and Kubernetes in detail, and basically build a real-world use case, a comprehensive end-to-end use case using these technologies. So basically, Dan will cover the aspects related to Codefresh and the importance of Codefresh when it comes to continuous delivery for cloud-native applications. Okay, so if I ask you a question, what is a cloud-native application? The typical answer that you will be giving is probably it's a methodology of building and running applications that fully leverages the power of cloud computing. So if you look at this definition, it's sort of an abstract definition, but we can identify some of the key characteristics of cloud native applications. So if you look at a cloud native application, it is comprised of microservices and serverless functions, right? So basically, when you are building a cloud native application, you identify different business capabilities and you build such capabilities as microservices or serverless functions. And once you build those decomposed functionalities as microservices and functions, then you package them into containers. So that's where our Docker and container management systems such as Kubernetes come into the picture. And once you package those services into containers, then you run a continuous to delivery model on top of those services and functions. Basically, you build a given feature and fully automate the entire development to deployment to production life cycle of a given functionality with the use of continuous delivery. So once you have the continuous delivery, you'll you'll streamline the deployment of your features into the production. And once things are running in production, you'll have dynamic management of the application. Usually we can call it the adaptive governance of your applications. So you run your application in your hosting environment, and based on the feedback channels that you have, for example, based on the traffic that you have, you can either scale up or scale down the application. And also you can build an observability ecosystem around your application using this managed dynamic managed applications. So if you look at the continuous delivery, it's the application of build, test, deploy, release, and develop life cycle. Basically, you start building application. Sorry, you start developing application based on a given business functionality, and then you build it. Then you build a testing framework, either unit testing or integration testing, and then you configure deployment, and then finally you release that into production, maybe across several other environments like QA, pre-prod, and prod. So what actually meant from continuous delivery is it's the process of shipping small batches of software into production constantly and with the use of automation. So if you are coming from any enterprise background, I think you are fully aware of the time it takes to ship a given functionality from development to production, right? So this is mainly due to the lack of continuous delivery models that we have in our organizations. So with the use of these new cloud native technologies, the continuous delivery of the features from dev to production is becoming much easier. Now, we talk about cloud native applications, right? So what is meant from cloud native programming? So here I'm using some of the quotes from Brendan Burns, who's the co-founder of Kubernetes and one of the well-known uh, architects around containers and cloud native applications. One of his arguments was we write code and then we use a set of descriptors to describe how our programs fit together. And his vision is on making life easier for the developers so that we can leverage most of the existing programming languages and build an ecosystem around those languages to make cloud native programming easier. So one of the gap he's trying to fill here is that most of these programming languages that we have at the moment are not necessarily designed to be cloud native. So that's why you have to write a lot of YAML files and plumb all these programs together using a separate technology. So his argument was, can we do this all in a single programming language? So he has been working on a new thing called Metaparticle to address some of these concerns. So basically building a application using any programming language and make it easier to create Docker and Kubernetes artifacts by using annotations. So that is and another aspect of cloud native application is now we identify different fine-grained functionalities and we break such functionalities into disaggregated endpoints, right? So basically we'll have serverless functions and microservices which are talking to each other over the network. So with this, with the proliferation of endpoints, basically every service and function that we disaggregate and that we develop will be exposed over the network, and they are plumbed together to make a given real world business scenario. So therefore, the importance of integrating these endpoints over the network is becoming really challenging. So that's why most of the existing programming languages has to deal with a lot of network calls, a lot of network interactions with these cloud native applications. So when you are building such cloud native applications or microservices, a major portion of your code will be basically on network interactions. So that's where you will have a lot of transformations, a lot of payload transformation, a lot of protocol transformation, and also you will build non-business logic related network capabilities such as resiliency using circuit breakers, timeout, read writes, etc. At the same time, you will have different security mechanisms, transaction protocols, workflows, streams, and likewise, there are a lot of network related stuff that you do as part of your code in addition to the business logic. Now, if we look at the available technologies for building these kind of applications, this kind of cloud native or microservices applications, what we have at our hand are the general purpose languages, of course, any language such as Java, Node, or JavaScript, or even frameworks built on top of those languages. What we observe is that they are not really integration simple. So integration in simple in the sense you don't have sufficient abstractions to make your network integration easier. So as we discussed earlier, there are a lot of network interactions that you have to deal with when you are building cloud native applications, but these languages does not have sufficient abstractions to build integrations in much convenient way. And if you look at the other extreme of the spectrum, we used to have the technologies such as ESBs, BPM, and EAI. Most of these monolithic solutions, they are of course not really container native or container friendly or cloud native, and also they're not agile enough. It's really hard to build something like continuous delivery or dynamic governance uh, with those applications, right? So what we actually observe here is that there is a gap between these applications. Basically, when it comes to building cloud native application integration, there is a void that we need to fill in. So the Ballerina, the cloud native programming language that we are developing, is the solution to that. So basically, it's a fully fledged programming language. It's a compiled type safe concurrent programming language, specifically designed for network interactions and building cloud native applications. And if you look at some of the design principles of Ballerina, so we used to do a lot of config driven integration with all these conventional tools such as ESBs and EAI tools, right? So in this approach, we uh, foster a code driven approach. Basically, you write code to build different types of integration, but you will get a lot of abstractions uh, to make your integration easier. For example, you will get language level abstractions to different network connectors, different network interfaces, as well as you have the notion of a service or a resource. For example, when you're building a RESTful service, you have a service and set of resources as part of the code. So those are the language constructs. And also we have the textual and graphical representation of the language. So basically you can build a given program using Ballerina and you can switch to the graphical view, or you can start from the graphical view and uh, also you can start from the graphical view and start building the applications. And graphical view is based on the sequence diagram, so that it makes much easier to represent that kind of interactions that you have in a cloud native applications. And also we offer first class support for different network data types such as JSON, protobuf, XML, etc. So those are built-in types in the language. And we enforce different types of best practices as part of the language. So you don't need to you don't need to run separate debugging or find bugs kind of tools. And also we have capabilities to make programs more secure uh, by default, as well as resilient by default. So basically you will find constructs such as circuit breakers, retries as part of the language. So with that, I would like to give you a brief demo on Ballerina, writing a simple service and how you can get started with Ballerina. So let me switch over to now, Ballerina, although it's a language, it has a whole ecosystem around the language. And if you go to ballerina.io, you can find different types of uh, learning materials. There are different examples, hundreds of Ballerina by examples on various integration capabilities and language capabilities. And also we have fully fledged end-to-end use case driven documentation. which is called Ballerina by Guide. So this has basically a use case written around a given technology. For example, if I go to Kafka, how we can do Kafka integration with Ballerina using a real-world integration. And so it has everything embedded into the guide, from implementation to testing to deployment to observability. Everything is part of a single guide. And so as part of the language, we have language ID plugins for different tools. So I'm using VS Code plugin for Ballerina in this demo. And also you can find other plugins such as IntelliJ plugins that you can use with your existing IDs. So let's try to, so first thing is you need to install Ballerina. So you can just download and install Ballerina. And when I just type Ballerina version similar to Java, it will print the version that I'm using. So let's try to build a simple HTTP service that accepts a request and send you back the hello world response. So as I said earlier, language has constructs such as service built into the language. So if I just type service, it will create the service skeleton. So I'm using HTTP interface for my service, hence I can import Ballerina HTTP package. And also we have a complete package management ecosystem. We have something called Ballerina Central, where you can download packages and push packages into the central repository. And since I'm using HTTP, now I want to create a inbound HTTP interface. So Ballerina defines the concept of an endpoint. So endpoint can be multiple things, right? An endpoint can be external facing endpoint. So for example, a backend service that you invoke from your microservice can be an endpoint. And also endpoint can be an inbound thing, inbound HTTP interface, inbound Kafka consumer. Those things can be an endpoint. So in this case, I'm using an endpoint to create an inbound interface called a listener. So this is a HTTP listener. So therefore, I need to give the port to my listener. I specified the port. And once I create this inbound interface, I'll bind that to my service. So let me rename my service to hello. And then I bind my service to the listener I just created. So now my service is so service can receive messages from this HTTP endpoint, which is a listener endpoint. And so as part of the Ballerina construct, you can build a service, and service comprises of multiple resources. So this is pretty much aligned with the RESTful service development concept. So let's say my resource is say hello. So, and so as part of the service code, so inside the resource, I'm writing my logic. Let's try to create a HTTP response, instance of HTTP response. So this is the response that I want to send back to my client who's invoking my service. And then as part of the response, I can set simply set payload, and I can give hello world. Okay. And now I discuss about the endpoint, the inbound endpoint. We are not using the outbound endpoints in use case. And also we have another form of endpoint called the caller endpoint, which is the client who's invoking me. So basically the client who's calling me is represented as an endpoint as well. So basically once I created the response, I can send the response back to the caller. And using this notation, respond, and I can give response as the outbound message. Okay, so and also so once I have done that, you can see an error pointing me, because this is actually enforcing me to handle errors. So because when you are invoking, when you are sending the response back to the caller, there will be an error that you need to handle. But if you want to ignore it, you need to do that intentionally. So this underscore sign will actually intentionally, I'm ignoring the error in this particular case. So this is all you need to do to make a simple HTTP call. And if you look at the code, there are two types of invocation. So this is a method invocation, which is a local call, and this is a network invocation, which happens over the network. So we use these arrow notations to denote anything that goes over the network is denoted using arrow. So you can obviously assume that how it works for the external endpoints. So again, we are using the arrow to invoke any external endpoint as well. So, and also you can, I mentioned about the graphical representation. So this will also generate a graphical representation for my service. Now it is based on the sequence diagram. So this sequence diagram is not that interesting because it's you're accepting a request, doing something and sending back a response. But just assume that you are using this service to invoke several other services or systems. You can see all the interactions in the sequence diagram in the form of different lifelines. So now we are all set to run this program. So you can simply run this program by running ballerina run hello world. Uh, uh, so I'm giving the name of the package. So you can simply run the service. So now let's start the service on this HTTP port. Now I can try invoking the service using curl. I'm running localhost service. My port is 9090, and by default the service name and the resource name become the URI or the context. Then hello / hello, say hello. Okay, my localhost. Okay, now you can see I got the response hello world back from my service. So this is very simple HTTP service, but you can extend this further. So I'm actually not going to cover everything related to Ballerina because there are a lot of previous webinars. I thoroughly recommend you to go through Paul's webinar on Ballerina, and it shows the entire end-to-end use case building with Ballerina and cover some of the fundamentals, as well as there are a lot of resources in ballerina.io to learn about Ballerina. And most importantly, the Ballerina is not just a programming language. It has the editing and debugging capabilities such as VS Code plugins and IntelliJ plugins, and built-in test framework called Test Arena, so that you can integration and unit test your applications. And also we have deployment extensions, which we'll be using in our today's demo, Docker and Kubernetes. So as I quoted from Brendan Burns, you can not every programming language support this cloud native deployment, but Ballerina does with the use of specific annotations for Docker and Kubernetes. And we offer observability capabilities out of the box with well-known observability tools such as Jaeger, Zipkin, Prometheus, and Grafana. And we have also dependency and version management and documentation generation, and also the central repository called Ballerina Central. Now we talk about Ballerina and integration of different types of endpoints. But when you build this kind of application that talks to multiple different systems, and then you need to deploy that into Docker and Kubernetes, and then you need to test, integration test, and fully build a continuous delivery pipeline for your applications. So this is actually becoming really challenging with the conventional technologies that we used to have, and also the programming language level support also really important to achieve this. But Codefresh, I think it's a uh, programming language agnostic framework for building continuous delivery for Kubernetes. Uh, I'll let Dan to go into details of Codefresh and elaborate on the importance of Codefresh in the context of cloud native continuous delivery. Dan, over to you, Dan.
Yeah, thank you. So the thing that I would just add to that is that in the old world, if you think about kind of the before even continuous integration, we had this issue where people had to manually integrate changes as they came in, and it was really time consuming, and it was flaky. And so this is why we introduced CI in the first place. But the challenge as you move into microservice based architectures is that the kinds of tests you do at the CI stage aren't robust enough. And so normally what people started doing is they would create like a staging server. They'd push all of their changes up to the staging server and they do the final check there. And that was after they had done their sort of continuous integration process. But that doesn't really scale, and it doesn't really work when you have this sort of microservice architecture. So what we really encourage people to do, and what we've really designed Codefresh to do, is once you make a commit, build your Docker file, build your Docker images, and then build and install. It could be a Helm chart, or in this case, Ballerina is actually solving the templating aspect of the configuration generation, the manifest generation. But install that Kubernetes application in a short-lived environment where we can run all of those integration, performance, and security tests, so that our CI process actually resembles a CI and CD process, because we can actually validate everything before production, and we can do it in a scalable way where it's non-blocking. We can have several people working on this at the same time, and then we can promote things up and then deploy into production. So that's kind of what this platform is designed for.
Yeah. Okay, so let's try to build a real-world use case using Codefresh, Ballerina, Docker, and Kubernetes. So in this case, I'm using the same Hello World service that I just developed, and then I check in my code to GitHub. Then Codefresh, at Codefresh level, I will define a pipeline to define my continuous integration and continuous delivery process, where when I have a new commit, new push into my GitHub repository, it will spawn up a new build from Codefresh, and it will also pull required binaries, required Docker images, as well as it will push Docker images to the supported registries. So basically, I'm using Docker for pull the base image for Ballerina into Codefresh, and Codefresh registry to push the image that we create with our Hello World service. And Codefresh allows you to define a pipeline that that can deploy directly into Kubernetes GKE running on Google Cloud Platform. So I'm using that in my demo as well. So let's get started with the code level changes. Now I mentioned about so with conventional languages, you just write code and then you have to work on several other tools such as YAML, using YAML to integrate with any of the deployment tools, etc. And also you have to manually create Docker files. But Ballerina makes it easier to integrate with all these tools such as Docker and Kubernetes. So let me show you a simple, so you can use some set of annotations on top of these services so that you can convert this into a cloud native application that can be directly deployed into Docker and Kubernetes. So the way that I'm actually using some copying and pasting some code to save time. So now I have the same service. Let me get rid of this comment. So I have the same service. Now I have defined few things. So on top of the service, on top of the endpoint, I have defined a Kubernetes service. And you can see I'm using the Kubernetes package from Ballerina. So so as part of the Kubernetes service, I have configured this service to be a load balancer. So basically leveraging service type load balancer to get the load balancer from the hosting environment and the name of the service. And as part of the deployment, so this is the Kubernetes deployment parameters. So this is the image name that I want to create. So here I'm giving the image name that I need to push into my Codefresh registry, which I'll be using as part of my Kubernetes deployment. And also, Ballerina allows you to build the image as part of the build process, but I don't want to do that because Codefresh will be doing that for me. So basically, I will only create the Docker image and deployment descriptors in this case. And I have set the pull policy to always to run the latest version, and also image pull secret. So this is used from, so I specified the Codefresh full secret. So from the GCP, when I pull the images, we will use this secret. So basically that's all you want to do, right? And of course I can try building the service locally as well. Ballerina build hello world service. So it will build, and also you can see it also ran some tests. So as part of my service, I have defined some test, right? So this is a simple hello world service, and basically as part of the test, you can see I'm using Ballerina's outbound connectors because I have developed a TTP service, and now as part of my test unit testing, I need to invoke this service and see what is the response I'm getting. So this is not just a local invocation, but this is a network invocation happens using endpoints. So here I'm using an outbound endpoint, which is a client endpoint, to invoke my service over 9090 with this context hello, say hello, and I am expecting uh, the response to be hello world from Ballerina. So it's a simple test, and everything is facilitated as part of the Ballerina test package. So now I have a test, I have a service running, and I have deployment descriptors. And once I build the service, you can see these artifacts are generated. Now, if I go to uh, target directory, I can see Kubernetes, and inside that the package that I'm using, hello world service. And here I can find my Docker file automatically generated. You don't have to do that manually. And also my deployment descriptor and my service descriptor. So you can further extend this to multiple other stuff such as ingress or config maps. Everything that is supported as part of the Kubernetes are supported through annotations in Ballerina. Now I have set up, now let me go to Codefresh. Uh, so uh, then do you want to go through the normal life cycle of building application with Codefresh, or I can just jump into my use case?
No, I just go ahead and jump in, and I can I'm here.
Okay. Okay, sure. So so again, from my experience, I have started off with Codefresh probably a few weeks back, and building the initial application and running is damn easier. So it's quite, and also the documentation and also the online help. I think there's a online chat that you can ask questions and get response. That's pretty fast and very helpful. So so therefore, building this use case is quite easier for me, and with the help of all the folks from Codefresh, it was pretty easy. So, so as part of the continuous integration and delivery process, you need to define a pipeline. So first thing, you need to set up a repository by pointing to your GitHub repo. So this is my GitHub repo for my Hello World service. So I have pointed from my Codefresh repository. So once I created the repository, I can define a pipeline. So pipeline is the place that I specify all the steps related to my CI/CD process. So in this case, you can see there's a trigger. There are some environment variables that I have passed, as well as some triggers. So this is automatically created trigger. When I push something into GitHub, it will automatically spawn a new build. And the workflow is the important aspect of this. So there are several steps in my workflow. So the first thing is to build the Ballerina package. Similar to what I have done locally, you can build in the Codefresh environment. And for that, so this is the name of the step and the title. And for each step, you can specify an image name that I'm going to leverage. Basically, in this case, I'm using, this is the Ballerina base image. Due to some of the limitations in the current versions, we had to, because we need to make it run as the root for some reason. So therefore, I customized my base Ballerina Docker image to remove running it as the Ballerina users. So it's a simple change that I did. So I'm using that image as the base image, and I have set fail fast to true, and some of the commands that I'm running as part of my build package process. Initiate the Ballerina and then run the same command that I ran locally. So once I'm done with that, I go to the build image process in Codefresh, and then as part of the build process, I'm pointing to the Docker file that I have created. So this is slightly different from the approach that Codefresh has taken with other languages, because other languages do not create these things out of the box. So probably the steps that we have in the workflow is far less compared to any other programming languages because of the out-of-the-box support for Docker and Kubernetes. So here I'm leveraging the Docker file that I have created as part of that the build process has created, and pointing to the Docker file. So it will generate a new image, and then coming into the testing phase. As part of the unit test, again, I'm using the Ballerina base image. I'm running the Ballerina test. So you can basically run Ballerina test and hello Ballerina test hello world service. So it will run all the test locally, right? And we can do the same inside my Codefresh environment. Inside my container, I'm running Ballerina test hellos. Now we are done with building, packaging into Docker container, and unit test in the application. And finally, we can deploy that my service into Kubernetes. So again, I'm not using the default Codefresh deployment plugin for Kubernetes. Rather, I'm using this Kubernetes Codefresh Helm plugin so that I can run kube control commands locally. So the reason for that is Ballerina has already created these artifacts during the build process, right? During this build process, it will create all these Kubernetes artifacts. So it's just a matter of running what I have. I just clean up the existing deployment. I ran it. Then I ran the entire Kubernetes descriptors that I created under this folder. So that's basically all the steps that we have in this entire development life cycle. And let me quickly show you an example just by committing something into my repository. Okay, so let me go ahead and change. Before that, I'll go into GCP. So as part of the deployment process, this has already deployed into Google Cloud Platform's GK engine. So the service is up and running in GCP. Okay, let me check the pods that I'm using. Okay, this is the pod that is already running. I'll get this VC, and I have my service running and type load balancer, and I can try invoking the service. Okay, give me the hello world from Ballerina. So let me go to this build section. So there is no ongoing build. Let me change the code a bit. And Codefresh. Okay, and I have to change the test as well. Otherwise, it won't get deployed into the GCP. Okay, I have done the change in my code as well as the test. I can of course run test locally and see the status. Okay, I'm good to go. Let me commit so I'll push that directly after the commit. Okay, I have pushed my changes. Let's wait. Now you can see there's a new build triggered, a pending build. Of course, you can see the status of the build as it happens. Now it's running the initialization process. And now cloning the repository from my GitHub. It's done. And now running build Ballerina hello world service, the Ballerina build process. This is where I create all the Docker files as well as the Kubernetes artifacts. But it hasn't created the image in the previous case. Now, this is the step that it creates the image. So actually Codefresh is creating the image. So Ballerina is not creating because I have specified Ballerina build image creation to false. So Codefresh creates the image in its environment. And yeah, still we are in the build image. Now running the test from Ballerina test framework. You can see test are passing, finally deploying that into GKE. Okay, so it's completed within 1 minute. I can go ahead and check the code. This is the production. Okay, now you can see it has updated with the new greeting message I have put. So you can see how easy it is to build something and push that into production. So I let Dan to go through the pipeline again, maybe if you need to add anything else.
No, the thing that I would just add is one of the reasons that I wanted to do this and invited and wanted to have Kasoon show Ballerina is because I think it's such an interesting approach to dealing with this sort of cloud native, Kubernetes world where most of the work that's out there is done to how do I Dockerize my application? How do I set up the networking? Let me create some Kubernetes YAMLs. Maybe I'll create a Helm package. And then you kind of manage the lifecycle from there. And what I think is so interesting about this is that all of the, those sort of infrastructure kinds of configuration, they're all handled automatically. And so it means that the deployment pipeline for Codefresh, we actually have less work to do because we basically can take the Docker file that Ballerina generated, we can build that, and then we can use Ballerina to run the unit tests, and then we can deploy and then run and use Ballerina's generated manifest to be deployed. So I think that's really interesting. And one of the things you'll notice here is as we built this, you'll see this unit test has this, the step is basically defined as an image, Kasoon and Dasari / Ballerina CF, because this is an image that we just built to run the, to run those unit tests. And so when you're working with Codefresh, basically every single step is its own container. And so you can specify your own image to run. And that makes every single Docker image out there a good sort of, you can almost think of it like a plugin, but unlike kind of a traditional like CI/CD system, you'd have to have a plugin that installs maybe for all users and is, you know, maybe has a version dependency on it, and I upgrade mine and it breaks yours. But here we've actually specified, you know, the tag specifically for the image, the version that we're going to use, so it wouldn't conflict with anybody else. We can work independently. So I think that's just really nice, and I think it's really cool, and big props to Kasoon for putting this all together, and all these resources and the secrets that are available here. You know, we can just use the context that we've already configured. Those are all things that I think made this pipeline pretty cool, and so good work, Kasoon.
Thanks, Dan. And also, one other thing that I would want to mention is, look at Codefresh. It is designed for like programming language. I would say dumb programming languages in the cloud native perspective. But when we want to extend it to a language such as Ballerina, or even something written on Metaparticle, for example, it's quite easier. We had the sort of low-level capabilities such as running Kubernetes configurations, kube control commands directly. So those are very interesting features. As well as I think there is a huge amount of other things that we haven't covered in this pipeline, which are offered from Codefresh. I think most of them are available in the Codefresh documentation. And as I said earlier, the help is incredible from the developers, directly from the developers, I guess. And also, probably we can compare the code written for this and maybe some other application. The number of steps that we have in the pipeline may be far less. So I think that is what we have planned to cover as part of today's session. And let me go back to the questions section. Anything else that we want to cover? So I think the code and everything will be available as part of the webinar, so you can try it out locally. Any questions you have?
Yeah, and while we're gathering those questions, I just want to add, you know, like Kasoon said, you can create a free Codefresh account and try this out yourself. You get 120 builds a month, so it's very easy to try out and get started with. I am seeing, Kasoon, this is a good question for you. The question from Jag is, how is Ballerina different from MuleSoft versus Oracle OSB?
Okay, yeah. So now, if we compare Ballerina with, as I mentioned earlier, EI and ESB tools. So even we from WSO2, we have our own ESB as well, right? So actually, when we were building the next generation integration platform, we were evaluating various ways of building integration, like using a DSL such as Apache Synapse or Apache Camel or even Mule. So using this kind of DSLs, what we will usually ended up with most of our customers is that we'll have a lot of custom code written from the native programming language of the DSL to make integration. So that is common with all the other vendors. But Ballerina, what we try to do is we brought in all the network and integration abstract as part of the language, and also it has all the programming language capabilities such as arrays, lambda expressions, as well as types such as JSON or XML. So I think that is the key differentiator, and things that I showed you, like the cloud native capabilities and the startup time, the boot time, within 1 minute, around 1 minute, everything is compiled, unit tested, and deployed. So I think that's a key differentiator from all these monolithic ESB or EI vendors. And we can, of course, compare with our EI solution as well, ESB solutions as well. So basically, this is something that we developed for microservices and cloud native application integration domain. And also there are some questions on how we have generated the artifacts. Maybe I can just show them again. Okay, let me go back to my UI. Let me get rid of the target folder again. Right. So when I do, so Ballerina has multiple commands. So you can either run Ballerina using Ballerina run and giving the package name or the folder name. So it will run the Ballerina. Also, you can do Ballerina build hello world service. Now you don't see any target folder. Now, as part of the build process, it will run the test as well as it will create these artifacts. So under target folder, so it will create the Docker file, and it will also create Kubernetes artifacts. So that's how it create these artifacts during the build process. There's a comment from Jack on nice GUI feature. I think that he's referring to Codefresh.
No, you mentioned sorry, so you guys got distracted here. You mentioned the integration, and for Codefresh and Ballerina, using it on-prem, not a problem. Codefresh does have an on-prem option, as well as a hybrid option where you can actually just run all the pipelines on your own infrastructure, but the management of it stays SaaS, which is kind of a preferred option. But yeah, I think we've covered it pretty well.
Yeah. And also, there's a question on how. We showed you how CI/CD and Ballerina works together with Codefresh, but Jack wants to know more about the integration capabilities. So one particular resource that I would like to point out is the previous webinar done by Paul, which you can find from the Learn section, and also any samples and guides that we have shows you different types of integration capabilities, like the Kafka one I showed you, the circuit breaker. So everything is actually covering a specific integration problem. So I think those are the good resources that you can learn and try out Ballerina.
Cool. With that, I think we're probably ready to close out. Don't you think?
Yeah, I think we have covered a lot today and a lot of interesting. Also, there's a question on managing secrets. We can manage Kubernetes secrets. So you can look at Kubernetes documentation in Ballerina, as well as we have a config API which can either get content from a configuration file, or the content can be encrypted. So it's on the Ballerina /config package. So you can use package. I think if you look at Paul's webinar, you can also see how you can use such capabilities. Yeah, I think with that we can wrap up. Thanks a lot for everyone for attending. So I think this webinar will be available as a recording for later reference.
Great. Yeah, thank you very much. And Taryn, any parting words? No, probably just a repeat of that.
Sorry, I just had to get myself unmuted there, Dan. No, thank you both so much for the excellent presentation. And yep, we'll be sending out the recording in just a couple of days, so look out for that. And Dan already reminded you, you can create a free Codefresh account at codefresh.io. And you can look out for our upcoming webinars from Codefresh as well on codefresh.io/events. We have all of our upcoming webinars as well as meetups on that page. So thank you both so much. And with that, I think we'll go ahead and end our webinar.